Hi, welcome to another amazing lecture with Chem Coach Powers for physical science. Today we're going to be doing something that's not in your book, so make sure that you're paying very close attention because you are not going to find this in your book, okay? It's important, and you're going to have some test questions on it, so take some good notes as you're watching this, but you're not going to have help from the book, so you better get help from me, all right? So if you have questions, please get with me, and I'll help you. So what these are called electron dot diagrams, also known as Lewis dot structures. And basically, we're going to be representing electrons, or valence electrons particularly, with little dots around the element symbols, okay? Now, remember the elements are more stable when they have 8 valence electrons. And so we're trying to get 8 electrons around these elements. Exceptions to that would be hydrogen and helium. Hydrogen likes 2, helium likes 2. There are other exceptions as well, but we won't worry about those for right now, okay? All right, so let us have fun. Here are some of these structures. Now, we have put a little X here in the middle just to kind of represent element whatever. And over here, you can see that we do have the elements: sodium, magnesium, boron, carbon, nitrogen, oxygen, fluorine, and neon, all with a different number of dots around them. Now, if you see one dot, that means that there's 1 valence electron in that atom, right? 3 dots would mean that that atom has 3 valence electrons, so on and so forth. That's what we're doing. You'll notice that they're in pairs a lot of times, and that's because you can fit 2 electrons in any orbital. And so sometimes you might spread them out, but if they're not spread out and they were together, you could still count those electrons. The reason we spread them out in cases like this is because we want to show that they will bond with multiple things. Like carbon likes to bond with 4 different things. And so you can see those 4 dots around carbon saying, hey, I bond with 4 different things. It's kind of the idea of it, okay? So I want you to take a second and I want you to pause and practice and write out what you might have just seen. See if you can figure out what these would look like. Okay, ready? And go. And we're back. And let's see what you came up with. Oxygen is going to have 6 total dots. Now, how do you want to put those dots? I don't really care how you put those dots, but I do like these to be in pairs and then have these one at a time. Now, maybe they were the other way around. Maybe you wanted to do the single dots over on the sides and you did the paired dots over here. That's cool. What if you did this? What if you were like, hey, I just put the 6 dots around like that? It's, like I said, it's not the best way to do it because we want to show that oxygen likes to bond with 2 things. You're like, well, how do I know oxygen bonds with 2 things? Well, because it's got 2 more spaces to add electrons to, right? It's got 6, it wants 8, and so it likes to bond with 2 different things sometimes, but it can bond with one other thing. In fact, one example where it bonds with one other thing is when it bonds with one other oxygen. And so is it totally wrong to put those 2 dots by there? No, it's not totally wrong, but we just kind of have a standard practice. Okay, so that was oxygen. Carbon, again, we could put 1 dot on each side. You do rock star status right there. If you had done 2 dots on each side, you know, not quite rock star status, but you're not wrong, okay? We appreciate it if you put 1 on each side. Magnesium, it's got 2 electrons. You put 2 like that, yeah, maybe not rock star status, but there you go, rock star status, right? Okay, that's kind of what we're talking about. You just want to show how many valence electrons there are around each element. And neon, of course, there's only one way to do that, 2 electrons around each side, okay? And neon doesn't typically bond with anything. It's already got 8 valence electrons. It's pretty happy. It's chill. All right, now compounds also get electron dot structures, but there are rules for writing these. And we're going to show you how to do the electron dot structure for NF3 and CH2O, but you've got to follow these rules. And again, these aren't in the book, so make sure you write these down. All right, so the first rule is figure out the total number of valence electrons that you have. You need to add them up. So we started with NF3, right? So nitrogen, I'm just going to put it over here. Nitrogen has 5 valence electrons. How do I know? It's in group 15, right? 15 and 5. Fluorine has 7 valence electrons in group 17, but there's 3 of them, NF3. So I've actually got 21 valence electrons just for fluorine. So if I have 21 electrons and 5 electrons, I've got a total of 26 electrons that I've got to place, right? If the structure is a polyatomic ion then you're going to have to add or subtract depending upon the plus or minus that you have. Again, it's not really that big of a deal, okay? Because I'm not going to give you a polyatomic ion. You'll get that in chemistry, but I'm not giving it to you now. All right, so then you've got to arrange the atom symbols. Typically, you're going to choose the central atom. You're going to choose the one that's the least electronegative, which basically means it's the one that is further over to the left or further down on the periodic table, okay? Carbon is oftentimes the least electronegative. Halogens like fluorine and chlorine and things like that, they're going to be terminal. They're not going to be in the middle. Hydrogen is never going to be in the middle. Okay, so you're going to choose the atom that will be in the middle that likes to bond with more than one thing. Okay, and so in this case, if I did NF3, I'd put N in the middle because fluorine is terminal. Fluorine isn't going to be in the middle. It's always going to be on an edge. And so then I would do that. I would put N in the middle, and I'd put my 3 fluorines around the outside. The next thing is to distribute the dots. The first way to distribute them is to do the actual bonds first, okay? So we want to first draw places where the bonds are. Okay, so I've got 2, 4, 6. I've put 6 little electrons in here, the bonds. Remember, each little line is equivalent to 2 electrons. And so now I subtract my 6 electrons out from my 26 that I had to start with. And that tells me I need to place 20 more electrons. And so then I start doing that. And I go 2, 4, and I start going around. 6, 8, 10, 12, 14, 16, 18, 20. Now, it happened to work out perfectly in this case that I just needed 20 more electrons, and that's my Lewis dot structure. However, there are times when you might end up running out, like maybe I ran out, then I hit 20 right there, and then nitrogen doesn't have 8, so now what do I do? Well, when that happens, you're always going to take from the ones that are happy, that have plenty, and then you're going to share those electrons in the little space in between the two, okay? And that's what it's talking about here. Double or triple bonds are sometimes necessary to make sure that every single atom has a full octet, okay? So yeah, we draw the bonds, and then if we were doing a polyatomic ion, we'd have brackets. Like I say, you're not going to have to worry about that. Again, just double check. Make sure that every atom has 8. So I want to double check. Nitrogen has 8. Why? Because there's 2, 4, 6, 8. Fluorine has 8. This counts. The one in between counts for both, right? 2, 4, 6, 8. This fluorine has 8. 2, 4, 6, 8. And this fluorine has 8. 2, 4, 6, 8. They're all with 8, so they're all happy. That's how we do Lewis dot structures. Okay, so those are the rules. And I just did it for NF3. You saw me do it there. I'm just going to kind of show you a little bit at a time there what it would look like. All right, step 1, count those valence electrons. 26 total valence electrons, arrange the symbols. Fluorine is going to be on the outside, nitrogen in the middle because nitrogen is the least electronegative. And then distribute our dots. Now again, I always start with the bonds in the beginning. You should always start with the bonds first and then go around and distribute the other ones, okay? And then check your work to make sure you got your octet satisfied. And yes, we are satisfied, so that's the correct structure. Now, let's do another one. Remember I said there were 2 of them. Let's do CH2O, okay? So first thing you got to do is count up all the electrons. Valence electrons, 1 for hydrogen, 4 for carbon, that's 5, 1 for hydrogen, that's 6, and then 6 for oxygen. I need to get 12 total electrons here. So my first thing I'm going to do is I'm going to put my bonding ones in first. So I'll put my bonding electrons here, here, and here. Now, I could just do a line. Here we're showing these big circles as electrons. Okay, that's cute. And then it's a little hard for you guys to see probably. And then the extra electrons are going to be placed. Okay, so how do I do that? Well, again, I got to get to 12, right? So I started with 12, and I just used 6 for my bonds, which means I got to do 6 more. Hydrogen's only allowed to have 2. I can't get any more for hydrogen because it can only hold 2. So now where am I going to put the other ones? Well, I put some here. That's 2 more, 4 more, and I need to put 2 more, okay? Carbon, if I put them up here, carbon would be happy, but my oxygen wouldn't. And so what I do, if I did that, I would say, oh, well, I got to put them in a place where they can share. And so now they can share the space. So now this oxygen has 8, and that carbon has 8. Remember, hydrogens are heavy. They only need 2, so they don't have to have 8. Hydrogen's an exception to that. All right, and again, how do I want to write it out? Like, I can put the O up on top. I can put it on bottom. It doesn't really matter where you put it. The arrangement isn't important as long as your electrons are in the right places. Okay? Okay, so just a little bit of a reminder. A single bond is when you have just 2 electrons shared. So if I were doing chlorine, I could show Cl and Cl, and then I could do my little dots around the outside. Okay. Double bond, I already showed you that one. In this case, it's 4 electrons that are being shared, and we would show that. And then nitrogen actually is kind of cool. It has a triple bond. In order for 5 electrons each to be shared so that each one has 8, you actually end up having a triple bond there. And so that's how you would do hydrogen. A triple bond would be 6 electrons total. Okay, so now we are wrapping up our objectives for types of chemical bonds. That was the part that wasn't in the book, but let's talk about the overall objective here. Can we now differentiate between ionic, covalent, metallic bonds? Yeah. Ionic, metal, non-metal, covalent, 2 nonmetals, metallic, 2 metals, right? The types of elements, okay? What kind of elements are ionic? It's going to have a metal with a non-metal, right? That's one of the things. The transferring or sharing of electrons. Ionic is transfer. Covalent is sharing. The structure, crystalline solids, okay? Covalents are not as, not going to have that same type of crystalline or the strength of the crystalline solids unless it's a network covalent solid. Properties, okay, solids at room temperature, liquids and gases and solids at room temperature, brittle, and then, you know, this is typically, well, a metallic is going to be malleable, right? Those are some of the things to think about. And then, can we draw models of the molecules using electron dot structures? That's the part that's not in your book. Yeah, now we can do that as well. So, you guys have learned some good stuff today. I hope you've enjoyed it. I hope you now know how to do Lewis dot structures. Might have been a little fast, might have been a little confusing, so make sure you ask me questions if it didn't, if it's not something you picked up on perfectly, okay? Because I'm here for you. I want you to have a great day. I hope you were kind to somebody today, and I hope you're kind to everybody today. What am I saying? Be kind to everyone. Have an awesome day, and God bless you.